Hello, welcome to a demonstration on how to generate multiple regression statistics using SPSS in a situation where you have some independent variables with a negative correlation. So really that is what is actually unique about this particular data set. You will observe that when you actually generate the regression statistics, age is actually going to have a negative relationship with the selling price of the house. So this is actually home sales, and we have square footage, and we have age as independent variables, and we have selling price as the dependent variable, right? So again, we are actually going to generate those regression statistics using this particular data set. As you can see, this data set is currently in Excel. So what we're actually going to do, we're actually going to import this data into SPSS, clean it up, and then be able to generate the relevant statistics. Okay, so here we are in SPSS, right? It's a clean page. Now we can go ahead to File, Import Data from Excel. And I do have the file that I actually need here in on my drive. So click on it, open, and after a few seconds you can see that it's actually making some progress here, and that's the file that we need. And of course it gives you some additional options here to remove leading spaces from string values, remove trailing space from string values. It's actually attempting to clean up the file because there are certain things that are not consistent with SPSS that will be in Excel, and in some cases you can actually have some blank columns that will actually come over as if they were actually real variables. So again, this enables you to clean up a little bit. So we can go ahead and say okay. And then we can see how the data is actually coming through. Here we can see our three variables, the two independent variables, square footage and age, as well as the dependent variable, the selling price. So it looks like so far everything looks about right. So, and we can scroll the way down to see how far. It's a very good sample size. Okay, so now we once we are happy with our data, we can actually go ahead and generate the regression statistics. But it's important to take note that in the SPSS, there's the data view where we can actually see the data itself, and there's also the variable view where we can actually go and make some necessary changes for the data characteristics. So we kind of define the data here. So it's always good to come here and just make sure that everything looks about right. The data type, the measures, the alignment, and things like that, right? So in this particular case, it looks about right, so we should be good to go. So we can go back to the data file, or rather the data view, and then we can click on Analyze, and under Analyze we should be able to find regression. If we move our point on regression, we see other options under regression, and we want linear. Click on it, and then of course we're actually good to go to generate the statistics, linear regression statistics. And of course, what is our dependent variable? We know it's actually the selling price. That's what we are trying to predict. So we select it and click on that arrow, show that that's our dependent variable. Then what is the next independent variable? We have square footage, and then age. Okay, and then of course in SPSS there's a lot of functionality. Do you want to have some plots? Do you want to have some options? Additional statistics that you may actually need. Statistical confidence level should be 95%. By default, it will be that anywhere. And then of course R-square change, any descriptives that you need. Again, it's a question of just figuring out what you really need as part of the regression statistics that are going to be generated, right? Then say continue, and then of course under plots, what is it that you actually want to specify in here? Do you want a histogram, a normal probability plot? There are a wide range of additional things that you can actually include in your generation, but in our case we just want to keep it basic, and we just want to generate the regression statistics where we'll be able to see the general regression statistics are the coefficient, the analysis of variance, which are by default the main statistical elements that will emerge from a regression a generation of those statistics. All right, so we can actually go ahead and say okay, and we should be able to see our results showing up. All right, and of course we have here, it does show you that this is actually our output, and there's a title, nodes, active data set, variable entered. So it's kind of just giving you all the background information. And then of course, the bottom three are the ones that really warrant any interpretation: the model summary, the ANOVA, and the coefficients. So what we're going to do here is we are going to walk through those last three sections: the model summary, the ANOVA, and the coefficient, kind of interpret the results that have been generated by SPSS. So model summary is kind of giving us a summary of the main regression statistics that have actually been generated for this particular model. And R, it represents the strength of the relationship. So the two independent variables, and that is the square footage and the age of the house, collectively they are at 88.2% strength. So that's pretty high, okay? Of course, if it was 1, that's going to be perfect strength. Then the R squared is just telling us how much of the variation in the selling price of the house is being explained by square footage and the age. It's telling us that it's about 78%. So 78%, so 22% are not explained, right? So we don't know which other variables can actually explain the other 22%, right? But generally speaking, in statistics, we always want to go with a more conservative measure. Instead of R square, we actually go with the adjusted R square, which is adjusted for the sample size. Okay, so it's a more conservative, so that will be still 77.3% compared to 77.7%. And the standard error is simply showing us the standard deviation adjusted for the sample size as well, how spread out or how dispersed the data is in this particular model. Right, so that's basically the model summary right there. The strength of the relationship, the coefficient of determination, which is how much of the variation is being explained by the two independent variables. Then analysis of variance, the main statistic here that we are concerned with is the statistical significance, collective statistical significance between the two independent variables and the dependent variable. So the number here, as you can see, it's less than 0.001, which means it is smaller than 0.05, right, which is actually our threshold because we used 95% confidence level, as you remember. Okay, so collectively, the two independent variables and they are statistically significant in their relationship with the selling price. However, in many cases, we also want to understand what all these other values actually mean under analysis of variance, the ANOVA section. We use the mean square of the regression and the mean square of the residual value to calculate the F-test, which we then use to calculate the statistical significant number. We also use the sum of squares of the regression divided by the total sum of squares to calculate the R square, right? But now here you'll find that there's actually scientific notation. You see here it's actually telling us that E plus 11, it simply means that the number, the sum of squares, the number is too large for us to include it or to fit it into this particular column. And so the basic interpretation of a number like this, 1.217E, E which represents, it's actually it is scientific notation. It means that we add 10 zeros to this after this number. So in other words, 1217 and then 10 zeros. So it's a very large number that's being abbreviated for our convenience right there. So it's always important to take note whenever you see numbers that are used together with some characters in there. They're simply telling you that it's actually scientific notation. The number is actually being abbreviated for our own convenience. Now, in situations where it was a minus 11, it means that the number would have been very small, right? Which means it's actually in decimal points. So in a case like this, it would have been to 11 decimal places. So when you see a minus, it means the number is too small. When you see a plus, the number is too large. So again, something to remember and take note of in future so that you can correctly interpret such numbers. And finally, the coefficient section. The primary focus here would be on the statistical significance or the p-value, right? In other statistical packages, this would be p-value, right? But here it's a sig, which is much better, statistical significant, right? So what does this mean? Square footage is less than 0.001, which means then it's smaller than 0.05. So square footage is statistically significant in their relationship with the selling price of the house. And so is the age. It's at 0.005, which is smaller than 0.05. Right, so both independent variables are statistically significant, and therefore the model is a reliable model. So these two independent variables are actually based on the data set that we're actually using in this particular analysis. They are reliable predictors of the selling price. Okay, so what else do we need to understand here? The coefficients, understand and standardized coefficients. Here it does tell us that for every additional square footage, right, the selling price will actually increase by $61, right? For every additional square footage, the selling price will increase by $61, but it can be as low as $55 and as high as $67, right? So it's important to take note of that. So effectively, the average of these two numbers here is what our coefficient really is, right? Okay, so again, you can always double check that, and I can guarantee that it actually checks out that way. What about the age? Here we can see it's actually negative. So it's actually saying for every additional age, a number of years, right, that's actually added to this particular variable, the selling price of the house actually decreases, right, in this particular case by $403, but can be as low as $685 and can be as high as $121, but all in negative. So age has a negative correlation with the selling price, right? The older the house gets, the lower the value gets of the selling price of that particular house, right? Does make sense, doesn't it? Right. So again, this really, this model really is what makes it unique compared to other types of models where they would have a positive correlation. In this particular case, square footage is a positive correlation. We increase the number of square footage, the value of the house will also increase. But with age, we increase the number of years, the value of the house actually decreases. But of course, there could be some outliers here and there. But again, always remember that you cannot necessarily take this to the bank, for lack of a better term, to say this applies in every situation. This can only be interpreted based on the data set that we have just analyzed, right? No more or no less, right? This is why in scientific research we always devote a good part of our paper explaining the limitation that should be taken into consideration whenever we are interpreting the results from any type of a research, right? Because we always want to make sure that we cannot overpromise anything, we cannot overstate anything at all, right? That's why scientific research is always referred to that way, because it must have that type of credibility when we are interpreting the data, because we cannot just willy-nilly overgeneralize the results that emerge from our results. Otherwise, that's all I have for you. I hope you find this demonstration useful. Not only the how to generate the regression statistics, but also how to explain the results that emerge from that analysis. Thank you so much for watching. And again, if you like the video, share the video, and of course like it, and be sure to subscribe to the channel so that we can continue to grow. Thank you so much for watching, and bye for now.